Fundamentals of counting, the multiplication principle, permutations, and combinations. The fundamental counting principle. If one event can occur in m ways, and the second event can occur in n ways, then the number of ways the two events can occur in sequence is m times n. Or in other words, the number of ways that an event can occur in sequence is found by multiplying the number of ways one event can occur by the number of ways that the other event or other events can occur. Let's take a look at an example. The access code for a car security system consists of 4 digits. Each digit can be any number from 0 through 9. How many access codes are possible if each digit can only be used once? Let's begin by drawing a diagram of the situation. So again, our access code consists of 4 digits. What are the possibility for each one of those digits? Since the digits range from 0 through 9, there are 10 possibilities for that first value of the access code. Because each digit can only be used once, 9 choices remain for that second entry of the access code. 8 remain for the third, and 7 for the fourth. Using the fundamental principle of counting, we see that there are 5,040 different access codes. Let's take a look at the situation if it is changed. The access code for a car security system consists of 4 digits. Each digit can be any number from 0 through 9. How many access codes are possible if each digit can be repeated? Once again, let's begin by drawing a diagram of the situation. There's 4 possibilities, or 4 digits in the access code. Because each digit can be repeated, we have changed the game a bit and see that there are 10 choices for the first digit, 10 for the second, again that value can be selected a second time, and a third, and a fourth. Now using the fundamental principle of counting, we see that there are going to be 10,000 different access codes in this scenario. Let's change the game once more. The access code for a car security system consists of 4 digits. Each digit can be any number from 0 through 9. How many access codes are possible if each digit can be repeated, but the first digit cannot be a 0 or 1? Always begin by considering or drawing a diagram and considering how many different possibilities exist for each of the digits. Because the first digit cannot be a 0 or a 1, that leaves 8 choices for the first digit. Since each digit can be repeated afterwards, that leaves 10 choices for each of the second, third, and fourth options. Using the fundamental principle of counting, we see that there are 8,000 different access codes. Another method that we have for counting is dealing with permutations. A permutation is an ordered arrangement of objects. Permutations are read as the number of permutations of n items taken r at a time. So be careful of recognizing we are given a number of items to select from, and we specifically select a number. Permutations follow a nice formula. The lowercase n represents the total number of items that we can select from. The lowercase r indicates the number of items to be selected. That capital letter P indicates that we're dealing specifically with permutations. And the formula on the right hand side is read as n factorial divided by n minus r factorial. Sometimes this can be viewed in a slightly different manner, but notice the formula is exactly the same. The expression n factorial is found by multiplying all integers from n down to 1 together. So the formal definition, n factorial, will be taking n, multiplying it by the next lowest integer, multiplying it by the next lowest integer, so on and so forth, all the way down to 1. For example, if we have 4 factorial, that indicates or that means 4 is going to be multiplied by 3, by 2, by 1. We can actually perform this multiplication. 4 factorial is just 24. If we take a look at 5 factorial, again that indicates that 5 is going to be multiplied by 4, 3, 2, and 1, indicating that 5 factorial is nothing more than 120. Let's take a look at an example of a permutation. On a team of 10 swimmers, how many possible 4-person relay teams are there? Again, the main thing that we want to remember about permutations are going to be that order is going to be important. We are selecting a specific number of items, and those number of items cannot repeat. In that 4-person relay team, a single person cannot swim 2 different relay legs. This would be an example of a permutation. there are 10 swimmers to select from, and we're going to specifically select 4. So we're looking to calculate 10 factorial divided by 10 minus 4 factorial, which simplifies and reduces to 10 factorial over 6 factorial. If we write out what those factorials indicate, we can see very nicely that anything divided by itself is always 1 or cancels out. So a lot of the terms are going to disappear when dealing with permutations. The only thing that we really need to multiply together is 10 times 9 times 8 times 7. So we see that there are going to be 5,040 different 4-person relay teams from the group of 10 swimmers. A Little League manager has 15 children on her team. How many ways can she form a 9-player batting order? Once again, recognize we have a permutation because order matters. Repetition is not allowed, and we are selecting from the same group of 15 children. So we have a permutation. We see that we're trying to calculate 15 factorial divided by 6 factorial. Okay, if we write that out, we'll see a lot of those terms are going to cancel out because anything divided by itself is always going to be 1 or it disappears. So the only things that we have to multiply together are going to be what remains in the numerator, and we see that there are 1,816,214,400 different 9-player batting orders from a group of 15 children. The last method of counting deals with combinations. A combination is an arrangement where order is not going to be important. Combinations are read as the number of combinations of n items taken r at a time. Again, we need to be careful that we are selecting from the same group of items, and those selections cannot be repeated. So no repetition is allowed either with combinations or permutations. N refers to the same thing as the total number of items or objects to be selected from, and r is the total number of items or objects actually being selected. Also be written or seen in a similar fashion. Let's take a look at an example. If a committee of 3 people are needed out of 8 possible candidates and there is not any distinction between committee members, i.e. the first selection is not the president, the second selection is not the vice president, so on and so forth, again, there's no distinction between committee members, how many possible committees would there be? All we care about is actually being selected to the committee, so order is not important. It does not matter if we are selected first, second, or third. All we want to be is on the committee. So therefore, order is not going to be important, and we're dealing with a combination. The same person cannot be selected all 3 times, so there is no repetition allowed. By filling this thing out, we see that we're dealing with 8 choosing 3, which means that we want to complete the following equation. 8 factorial divided by 5 factorial times 3 factorial. Once again, if we write out what those factorials indicate, we'll see very nicely that many of these terms will cancel out or disappear. Remember, anything divided by itself is just 1 or cancels out. So we really just need to multiply 8 times 7, and we can see that there are 56 different possible committees of 3 people when choosing from 8 possible candidates. The Florida Lotto game is typical of state lotteries. You must select 6 different numbers between 1 and 53, and no number can be selected more than once. You win if the 6 numbers are drawn in any order. Find the probability of winning the jackpot. The whole reason that we talk about the different methods of counting is because the sample space might be too large to actually draw out. We need a different way to determine the sample size or the number of possibilities that satisfy the given event. We can use either permutations, counting, or the fundamental theorem of counting to calculate or determine either one of these possibilities. Since we're determining a probability, we know that we want to determine the number of winning tickets and divide that by the number of possible tickets. In order to get a winning ticket, all 6 numbers must be correct. So that means that indicates that there are 6 winning numbers and we must choose all 6 of them. Since order is not important, we see that we're dealing with combinations, so 6 choosing 6 turns out to be 1, or there's just 1 winning ticket. We want to divide that by the number of possible tickets. The number of possible tickets can be determined once again by using one of our counting principles. There are 53 numbers to choose from. We only need 6 on any given ticket, so it turns out, since order is not important once again, 53 choosing 6 turns out there are 22,957,480 different number of possible tickets. We see then that the probability of a winning ticket is going to be 1 divided by 22,957,480.